about 10 years ago, we started extracting natural gas from shale, which is a new way to get natural gas. The old way was fairly difficult and risky, and you had to drill directly in the right spot. But now you don't have to do that. You don't have to look for any geological domes. You can get it right out of the rock itself, and the rock is shale. Alright, shale is a sedimentary rock. It forms in thick slab layers from deposits of marine organisms. And guess what? This part of the country, 2/3 of Pennsylvania and into Ohio and West Virginia and Kentucky, was an ancient shallow ocean, perfect for deposits of marine organisms. So as that sediment was buried and put under geologic heat and pressure, it turned to rock, in this case shale, rich in organics, which later became natural gas. And now what we have to do is go down into that rock layer, the shale, and we can tap into it and extract natural gas as an energy source. Okay, traditionally we used to have to drill for natural gas. This was the traditional method. Traditionally we had to find these sources where natural gas and oil was together. Now we don't have to do that anymore in the case of the shale. A large deposit of shale covers about 2/3 of the state of Pennsylvania, going into New York, Ohio, West Virginia, Maryland, down into Kentucky. The shale formation is called the Marcellus Shale, and you need to know that. That's the deposit. That's the rock, the Marcellus Shale, that was deposited millions of years ago, that is rich in natural gas resource. So that's what we're looking for, deep underground, all over the state of Pennsylvania. And here's what it looks like. And you can look at Montgomery County down here. All right, we don't have any Marcellus Shale under us. However, 2/3 of our state does. And if you look up here, most of this area of green is being tapped into for natural gas drilling. There is one line, and I don't know exactly where it is, but it might be just around this area. There's no fracking going on over here. All the fracking is going on to the left and to the west of this line. And you can think about what that line might be. Alright, there's no fracking to the east of this line. And what you're looking at is the line that marks the Delaware River watershed. So, for example, if there was an accident over here to the east of that line, the material and the contaminants would migrate through creeks and streams and groundwater supplies to the Delaware River, where it would then contaminate the Delaware River, which is where your town, among others, get their drinking water from. Alright, so the Delaware River Basin Commission and some other advocacy groups for the river have kept fracking out of the Delaware River watershed as of right now. Nevertheless, it might be just a matter of time until companies move into the Delaware River watershed. But right now it's still delegated to the Susquehanna River watershed in the central part of the state and over into the Ohio River watershed. Right, so it's something to think about. And here you go. You can see the extent of the Marcellus Shale and another deposit that's next to it called the Devonian Black Shale. So a lot of natural gas in and around the mid-Atlantic states. Tremendous amount of resource. We're talking about trillions and trillions and trillions of cubic feet of natural gas. And Pennsylvania is great to do this in because if you obtain resource here, you literally build pipelines, which is what they're doing. Alright, and you pipeline it down to the refinery, which is in Philadelphia, and then you can ship it out onto the world market. Most of the natural gas that we produce is actually exported. Alright, a lot of people think that we use it, and you'll see reports of people talking about that it's a domestic source and we need to use it for ourselves, but you need to know that most of it is exported. Remember, fuel sources are a worldwide scale, not just the United States. So if you can get more money for the product, that's where you're going to go, and for right now it's overseas, so most of the natural gas gets exported. Alright, and here's what a drill rig look like. Just a vertical drill rig. Alright, very localized place, very localized operation. These things dot the landscape, and in numbers there's a significant impact. Okay, take a look at this map right now. What we're looking at is natural gas production in types of natural gas. Okay, so if you look here, there's something called tight gas or coal bed methane. Here's natural gas associated with oil deposits, which we talked about. But if you notice, all of those sources of natural gas have been declining over the past years. The production of natural gas of those sources has been going down. But look at shale gas. Shale gas has been exploding and is projected to into the future. This becomes our main source of natural gas in the United States. So if we are going to use natural gas as a transition fuel, moving away from other sources like coal and oil, shale gas is where the potential lies. All right, so we need to understand this very important topic and both the benefits and the consequences of it. Okay, so let's do just that in starting a discussion about hydraulic fracturing and how we get natural gas. Okay, so like I mentioned, okay, this is a drill well, and you literally drill vertically underground. And 25, 30, 40, 50 years ago, this used to be the method, vertical drilling to get to deposits. So what you had to do is you'd have to drill in this location, then you'd have to drill in this location, then you'd have to drill in this location. And too many wells were popping up, and it was very costly and expensive to do that until about 10 or 15 years ago when a gentleman from Texas developed a way to actually drill horizontally. So now what we can do is horizontally drill into the shale deposit. This becomes a very efficient, successful way to obtain natural gas through horizontal drilling. Okay, so you drill vertically and then horizontally into the deposit, and now you only need one wellhead, and you can drill thousands of feet horizontally underground, deeper than any water supply. All right, we're under any aquifers. Let's show you the aquifer here, and let's drill a well and tap that aquifer so that this home here has drinking water. Alright, so we're well below any aquifers, we're below coal beds, we're below impermeable boundaries. Okay, let's make an impermeable boundary here. Okay, and what we're going to do is we're going to frack this gas shale. So by fracking, what we're talking about is a process of obtaining natural gas that is very safe if it's done right. Okay, and that's the important thing here. I need to stress the point that this process is okay to do. It's completely fine as long as it's done right. And as soon as steps are skipped or as soon as it's not done right, that's when accidents can happen or things can go wrong. So what hydraulic fracturing means is to drill down vertically and then horizontally, and then what we're going to do is we're going to shoot down little explosions or little bombs. They call them perforator. All right, and perforator gun is going to go down here to the bottom of the well and cause little mini explosions, which is going to crack the shale. All right, so that's our goal, is to crack the shale so that it's going to free up natural gas that's locked up in the shale, and the natural gas can then literally float out of those cracks and into the well and up the well for production, so that we can collect it and take it away and use it. Now, a couple things of note here. These little perforator guns that crack the rock, and these cracks are now open. That's not good enough. What we need to do is make sure that those cracks remain open so that gas can continuously flow up the well, and we can just continually collect natural gas from this deposit. So what we're going to use is fracking fluid. And fracking fluid is an interesting thing. All right, it's 99.5% sand and water. All right, the other 0.5% are many different chemicals used for many different reasons. There's lubricants, there's accelerators, there's all kinds of different chemicals in there inside of the fracking fluid that are used for different reasons in the process. But what you're doing is you're using anywhere between 1 and 7 million gallons of water every time you frack. Okay, and you're infusing chemicals, some of which are known and some of which are unknown, right, because of trade secrets and things like that. You're infusing unknown chemicals into 7 million gallons of water to be used to open up these cracks and to accelerate the process and to allow more and more gas to flow up the well. But you're creating a lot of hazardous waste in the meantime. All right, that's 1 to 7 million gallons of water becomes unusable, and it actually becomes hazardous waste. So as we inject our fracking fluid down this well, all right, and it goes down in here to open up these cracks to facilitate production. The sand is used to open up the cracks and keep those cracks open. The water will go down, do its job, and then it is actually pumped back up. If you put down 5 million gallons, you might only get 1 million gallons back. You might get 2 million gallons. All right, some stays down and some comes back up. The water that does come back up is treated as hazardous waste and has to be stored on site in what's called surface impoundments. We'll get to that in a second. Nevertheless, that fracking fluid is used for the production of the well. Now, here is one of the issues with this process. When you drill this well, the proper procedure is to line this well as far down as possible with a layer of concrete and steel. All right, and then another layer of concrete and steel. So what you've done is you've created an impermeable casing, right? This is a well casing to your well. So as this hazardous fracking fluid goes down and back up again, that well casing is going to protect groundwater supplies, the surface, from being contaminated from fracking fluid. All right, and this becomes one of the other controversies, because if the well casing is installed incorrectly, or if there's a small earthquake, or if the well casing is not installed at all, fracking fluid or natural gas can come up the well, and if the well casing has been compromised in any way, the contaminants can flow out into the groundwater table. All right, and then as you can predict, it's going to be pulled up the well, and now this house here can light their water on fire because of the methane or natural gas that's in their water supply. Or they could be getting headaches, or they might develop cancer, all right, from some of the chemicals in the fracking fluid. All right, so when there's groundwater contamination, there's all kinds of not only human health effects, but the compromise of water supplies. Okay, so that's natural gas production in a nutshell. That's fracking in a nutshell. Like I said, if it's done right, these deposits are very deep between impermeable boundaries. The well casing is installed correctly. It's completely fine. You may have an accident here or there, but that's normal for industry. If it's done right, it's okay. So now that you know what fracking is, let's take a look at some of the environmental impacts that we haven't spoke of already. All right, if you look at this well site here, you see fracking fluid being stored on site in these large containers. Okay, and then you see the well casing here, which is the thick black line, adjacent to the well. You see methane being produced and is coming up the well. The cracks of the shale are allowing gas to flow freely through the well. But you notice a couple things. Down here in the lower right-hand corner, it's been recorded that the perforator guns, or the pumping of the fracking fluid down and out of the well, could cause mini earthquakes. So mini earthquakes become an issue with fracking. I don't want you to think that these are triggering 7, 8, 9 on the Richter scale type earthquakes. Right? These are very small mini earthquakes, but they can have somewhat of an impact. Also on the surface, when the fracking fluid comes out, you'll see these wastewater ponds. All right? If you remember from hazardous waste, we call these surface impoundments. A temporary storage for hazardous waste. A couple of issues with these surface impoundments. All right, it could overflow, and now you have fracking fluid going into a local stream or river. All right, it could the liner that they're supposed to have could leak, and now you have fracking fluid seeping into the groundwater. All right, you can have birds or animals try and land in these ponds. All right, any number of things that can happen to these surface impoundments that can allow this fracking fluid out into the environment. So this is a little bit about what the site might look like. Again, very localized, all right, but that's a natural gas production site. Okay. Here's one in western Wyoming where drill heads are, encompassing a large area. As mentioned, with the Marcellus Shale formation, we here in Pennsylvania are partaking in the natural gas boom. It shouldn't shock you to hear that Pennsylvania is involved in this energy boom. Remember, we're an energy state. We have a long history with coal. So to partake in extraction of this energy resource, natural gas, should not be really surprising. All right, we're an energy state. We have been, and we will be into the future. Okay, so here you go. Here's an image of a production site. Okay, you got your surface impoundment, you have your drill, and your tanker trucks full of fracking fluid. All right, here's another surface impoundment. Okay, very small localized area. You see the woods are still intact. Here's a farm or a home. And there you go. Okay, some of the impacts. All right, we mentioned mini earthquakes. This picture does a nice job of showing you the sheer amount of water that goes into the production of a well. And this is an actively produced well. All right, here's the valve where the natural gas will be extracted. All right, here's a little pipe laying on the ground here, so they'll hook this pipe up to this valve when they're ready to turn it on, and it'll literally be pipelined away. All right, that pipeline might reach all the way to Philadelphia. But in the production of natural gas, all right, a tremendous amount of water is used. All right, like I mentioned, 1 to 7 million gallons of fresh water is used. Now, fresh water is a dwindling resource on Earth. All right, it's going to become increasingly more important into the future as a resource. And here we are using 1 to 7 million gallons per wellhead. And there's hundreds of thousands of wells all over the country. And you need to use 1 to 7 million gallons every time you frack a well. All right, and you can frack a well up to 18 times. So we're talking about billions of gallons of water that have now been contaminated with chemicals and need to be treated as hazardous waste. So we're ruining billions of gallons of water in this industry. So that's a concern, and that's one of the environmental impacts of how we get natural gas from shale. Okay, a third one is the surface impoundment. Okay, here we are pumping fracking fluid into the surface impoundment, which is temporary storage. Okay, and if you notice, there's a fence around here to keep animals out. Sometimes they'll put like strings across this with little pans or plastic bottles hanging from here so that they rattle in the wind to deter ducks and geese from laying in here, and that's a good thing. Okay, but what we have to really worry about, and this one is properly lined, these liners can break. All right, and if the liner breaks, you have groundwater contamination. Or if you have a heavy rainstorm and this thing overflows, now you have surface and groundwater contamination. All right, so surface impoundments and that method of storing hazardous waste at the surface is very risky, to say the least. Typically what they want to do is evaporate that water. Sometimes they'll put giant heaters here and try and heat the water so that the water evaporates and the chemical residue is left behind. All right, and then that can be collected and treated as hazardous waste, shipped off site. Okay, so a third impact is that of the surface impoundment. Here's a little bit about the fracking fluid. Understand that it is 99.5% sand and water, but those other chemicals, there's many. This just shows just a few. It can be hundreds. All right, anything from gelling agents to scale inhibitors to pH adjusting agents to corrosion inhibitors, surfactants, friction reducers, all kinds of different things, some of which are known and some of which are unknown. A fourth impact is the groundwater contamination from the production itself. Okay, if a well is improperly lined, fracking fluid or methane in the form of natural gas can leak out of the well itself and into water supplies and can cause human health impacts, and both short-term and long-term. Okay, so this is a big one. One that's not really discussed is the transportation of the natural gas. All right, so we could put number 5, transportation via pipelines. All right, right now we're seeing an increase in the amount of pipelines in Pennsylvania, and it's this natural gas boom that is responsible. So when you lay a pipeline down, what you need to do is cut through nature to lay that pipeline down from the production fields all the way down to the refineries or where it's going to be exported or shipped out. Okay, so cutting or fragmenting habitat is a problem. Okay, whenever you make a cut, you should remember this from our biodiversity unit. When you fragment habitat, you've now impacted the ecology of the region. Okay, heavy machinery is used to lay the pipeline down, and the pipeline is just a bit underground. It might be 4 to 6 feet underground, but that heavy machinery compacts the soil and increases runoff, so you have sediment pollution, or it inhibits infiltration of rainwater. So you'll have significant problems with either flooding or sediment pollution in these areas where pipelines have been laid down. All right, so there's all kinds of different things that can happen with pipelines. They could explode. All right, anywhere a pipe comes out of the surface and there's a valve, there has to be a valve every 20 miles. All right, and that's a place where the pipeline actually comes above the surface and is a place where it can be regulated or monitored. All right, but every 20 miles you have a valve. Whenever you have a valve, there are leaks. And it's been researched that 6% of the natural gas that's being transported is lost during transmission. All right, so you can think to yourself, that's a significant amount of gas lost. All right, so anytime you have a seal, gas leaks out. Also, along the way during transmission of the natural gas, every once in a while there's a compression station. All right, these compression stations are built above ground. It's above ground infrastructure. It's a building with valves and pipes. These compressor stations are designed to monitor and regulate the flow of the natural gas along the pipeline during transmission. But there's so much pollution that comes out of these. Things like volatile organic compounds are released, right? Nitrous oxides, there's carbon dioxide and carbon monoxide, there's particulates, lots of air pollution coming from these transfer stations, which are I think that's every 100 miles. There needs to be a compressor station. Okay, so lots of cumulative effects of the extraction of natural gas and the production of this resource, and we have to look at it in a cumulative way. Okay, so here you go, just a little bit of a summary of what we just talked about. And if you have any questions, please bring them to class. But just understand how important natural gas is as a resource. All right, it's going to be our transmission. It's going to be our transition fuel. Okay, we have a lot of it. All right, although it goes on the world market, we do have a lot of it to use. All right, we just have to be aware of the cumulative environmental impacts of how we extract it. And I'll leave you with this image. All right, before we finish, we have to take a look at the fraccidents. And if you notice here, there are accidents all across the country. Okay, you're going to have accidents. But take a look at Pennsylvania. Okay, we are doing something wrong when it comes to production of natural gas. And it just might be the lack of regulation. Right? We need to make sure that these companies are installing proper well casings. Okay, we need to make sure that fracking fluid is not leaking into groundwater supplies. Okay, something needs to be done here. You can see across the country that fracking is okay. You will have some accidents. That's just a part of industry. But we're not doing something here in Pennsylvania. And we need to be concerned with what that is. We need to figure this out, all right, especially as we move into the future and continue to extract this resource, and especially as this extraction method moves into the Delaware River watershed. Okay, so hopefully now your eyes are a little bit more open to natural gas as a resource that can take us into the future, but also to some of the cumulative environmental impacts of not only the drilling and the extraction, but of the transportation process of this resource.